Welcome to Let Me Fix This. Enjoy the video.
Using an AMD GPU for machine learning requires the ROCm software stack installed. ROCm provides kernel drivers, ROCm libraries, and MI-open accelerated primitives for neural networks. You can run PyTorch ROCm builds or TensorFlow ROCm packages directly on the stack. Check GPU compatibility lists and prefer cards with 16 GB or more memory for larger models. Enable FP16 mixed precision to reduce memory and speed up training. Start with batch sizes like 32 for balanced throughput and stable convergence. Install the ROCm meta packages and matching kernel modules for your Linux distribution. Use the ROCm version recommended for your kernel, for example ROCm 5. 6 for recent kernels. Install matching PyTorch ROCm or TensorFlow ROCm wheel packages built for that ROCm release. Reboot the system after installation to load kernel drivers and ROCm modules properly. Verify installation with ricminfo and check that /opt/ROCm/bin/hipk compiles a simple HIP program. Ensure user permissions allow access to /dev/kfd and GPU devices. Use MI-open convolution kernels and the ROCm-optimized math libraries for best throughput. Profile training runs using ROCprof or the PyTorch profiler to identify CPU-GPU synchronization bottlenecks. Adjust data loader num workers to saturate GPU I/O without causing CPU contention. Prefer FP16 mixed precision combined with loss scaling to maintain numerical stability. Use gradient accumulation when batch sizes exceed memory limits. For example, accumulate 2 steps to mimic batch size 64. Monitor GPU temperature and power. Tune GPU clock and memory limits only if thermals remain safe.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.